everyone, so today we're going to be doing the notes for section 6.2. This section is on conditions for rectangles, rhombuses, and squares. A reminder from yesterday, parallelograms have 4 properties in addition to the definition of parallelograms, and so those are highlighted here in yellow. Remember, a parallelogram, both pairs of opposite sides are parallel, but then in addition to that, the opposite sides are congruent, the opposite angles are congruent, the diagonals bisect each other, and the consecutive angles are supplementary. They add up to 180 degrees. And this picture here on the notes has all of those markings, all of those congruence markings indicated on the picture. Today's notes are going to cover properties for 3 additional shapes. These are also all quadrilaterals, so we're going to talk about the properties for a rhombus, for a rectangle, and for a square. A rhombus is a type of quadrilateral where it has all the properties of a parallelogram plus the following properties. So in a rhombus, all 4 of the sides are congruent, the diagonals are perpendicular, and then the diagonals bisect the angles. And all of those congruence markings are added here on this picture as well. A rectangle is probably one that you're a little bit more familiar with. A rectangle has all of the properties of a parallelogram, plus all of the angles are 90 degrees, they're all right angles, and the diagonals not only bisect each other, but they're also congruent to one another. And then the last type of quadrilateral that we're going to talk about is a square. So a square has all of the properties of a parallelogram, plus all the properties of a rhombus, plus all the properties of a rectangle. So it has all the properties combined into one. So this next section of your notes has properties listed, and you're asked to circle the shape that it applies to, and you're asked to cross out the shapes that it doesn't apply to. So you're going to be circling different numbers of shapes in the different problems. Let's go through and do the first one together. So consecutive angles are supplementary. That means that the angles that are next to each other add up to 180 degrees. So that's true in a parallelogram, and then it's also true in a rhombus, a rectangle, and a square, because remember, those 3 shapes are all different types of parallelograms. So the consecutive angles are supplementary on all of those shapes. Same thing with number 2, the diagonals bisect each other. That's true in a parallelogram, and so if it's true in a parallelogram, it's true in a rhombus and a rectangle and a square, so you're circling all 4. In the third statement, all sides are congruent. That's true in a rhombus and it's true in a square, but it's not true in a parallelogram or in a rectangle necessarily, that all 4 of the sides are congruent to one another. So you would cross those ones out because that does not apply to those. All right, for these next ones, number 4 says both pairs of opposite angles are congruent. That's true in a parallelogram. So it's true in a rhombus, in a rectangle, and in a square. But on the next one, on number 5, it says all angles are congruent to one another. So that's true in a rectangle and in a square, because the angles in a rectangle and a square are all 90 degrees, but it's not true for parallelograms and rhombuses. And so you would cross those ones out. And then for number 6, the last one on this page, it says the diagonals are perpendicular. So that's true in a rhombus and in a square, but it's not true in a parallelogram or a rectangle, so you can cross those ones out. All right, moving on to the back side of your notes. So property 7 says the diagonals bisect the angles. So that's true in a rhombus and in a square, but not for a parallelogram or a rectangle. Number 8 says both pairs of opposite sides are congruent. That one's true in a parallelogram, so that means it's also true for a rhombus, a rectangle, and a square. And then the final property says the diagonals are congruent to one another. So that's true for a rectangle and a square, but it's not true for a parallelogram and a rhombus. The next section in your notes goes through setting up and solving some different kinds of problems where you have to use the properties to set up and solve equations. So here in this first example, it says QRST is a parallelogram, and you're asked to go through and solve for x. Remember, you're going to be using the properties to decide how to set up the equations. So in this one, the 2 angles that are marked are next to each other. That means they're consecutive angles, and the property says that consecutive angles are supplementary. So I'm going to take 80, I'm going to add it to the 14x plus 2, and I'll set that equal to 180 because those are consecutive angles, so they should be supplementary. Combine like terms, so 80 and 2 gives me 82, and then minus the 82 from both sides, finish by dividing by 14. And so for this one, I get x is equal to 7. X is the value that I'm solving for, so I don't have to go back in and plug that in for anything. For b, there's 3 values that we're trying to solve for, so this one's going to take a little bit of extra time. The first one that I solved for is a, and so to solve for a, 14a plus 20, I looked at the picture where I saw the a. Notice how that's pointing at one of those angles that are in the middle, and so that's how I knew how to set up this equation right here, that 14a plus 20 equals 90. That's because that angle is pointing at the intersection of the diagonals. I know that in a rhombus, the diagonals are perpendicular to one another. So I'll minus the 20 from both sides and then divide by 14. So I'll get a equals 5. When I do the work for b, I use a different property of rhombuses. So to solve for b, I look where the b's are in the picture. The b's are on opposite sides, and I remember that the rhombus is a type of parallelogram, so the opposite sides are congruent. So I set 3b plus 4 equal to 13b minus 9, and I go through and I solve there for b. So I minus the 3b from both sides, I added the 9, and divide by 10. And that gives me the b is equal to 1.3. The last value that you're solving for in this problem is c. This one's a little bit tricky. C is over here on the picture. It's one of the angles that's marked over here on the side. But in order to solve for c, I have to first right here plug in the number that I got for a to figure out what that little angle of that triangle is. So when I plug in the 5 for a, I get that that angle right there is 20 degrees. And then to find angle c, I'm going to use the fact that right here inside of the rhombus, I have a little triangle. And so that triangle equals 180 degrees, the three angles in that triangle do. So the 90-degree angle in the middle plus the 20-degree angle that I just solved for plus the c angle that I'm trying to figure out gives me 180 degrees. And so I can combine like terms minus the 110 from both sides, and I get c equals 70. What these questions all have in common is you're using the properties of each shape to decide how you're going to set up your equations. So on this one, it tells me that ABCD is a rectangle. I know that because it's a rectangle, the diagonals bisect each other. And I know that all four of the angles are equal to 90 degrees if we need to use that on this question. For the first part, I'm going to solve for x. X is down here, x is down here. And so I use the fact that the 50-degree angle makes a vertical angle with the other 50-degree angle. And then because the x is across from the 3 centimeters, I know that that other angle is also going to be the same thing as well. So I could label that other angle as x right here. And so inside this little triangle here, I'm not going to use the 3, but I'm going to say that 50 plus x is equal to 180 degrees. So inside that little triangle that gets formed, I know that the 3 angles should add up to 180 degrees. So I'll combine like terms. I'll minus the 50 from both sides, and I'll divide by 2. So for that one, I'll get x is equal to 65. The next part of this question wants me to solve for AC. And so AC is that whole diagonal that goes across the rectangle. I know that one piece of the diagonal is 3 centimeters, and I know that the diagonals bisect each other. And so I can do 3 plus 3 and get 6 for that. All right, for this next one for letter D, it says the figure is a rhombus. I know because it's a rhombus, I know the diagonals bisect the opposite angles. So that's how I was able to write in those 48s in both of those places. The 48 degrees is half of that bisected angle. And so I can create the equation over here because down here in this triangle on the bottom, x plus 48 plus the other 48 has to equal 180 degrees. So I'll combine like terms, and then I'll minus the 96 from both sides. And that's how I get that x equals 84 on this one. All right, the last two examples on today's note have an extra step because based on the information that's given to you in the picture, you have to try to state what the most specific name for the shape is. So for this first one for A, the shape would be a square. And the reason is because all of the sides are congruent and all four of the angles are 90 degrees. And so we're going to go through and solve for x and solve for y. Remember that you're going to be using different properties to solve for each of these. Notice that the x's are marked on the sides. So 2x and 6x minus 9 are equal to each other since all four sides of a square are equal to one another. They're marked that way in the picture. And so right here, I'll set up and solve this equation. I'll minus the 6x from both sides, and then I'll divide both sides by -4. So I get 2.25 as my value for x. And then the way that I go about solving for y is different. Notice that the angle for y right here is marked in the center where the two diagonals of the square intersect one another. And we know that the diagonals of a square are perpendicular. So I'm going to set 2y plus 10 equal to 90. Since that angle is equal to 90 degrees, since the diagonals are perpendicular, I'll minus the 10 from both sides and divide by 2. And so for this one, I'll get y equals 40. All right, and for the last one, based on the information that you're given in the picture, you can say that the most specific name for this one is a rhombus, since you see that all four sides are congruent to one another. And so again, we're going to set up and solve different equations to figure out the variables that are indicated here based on the information that's given to us in the problem. So to solve for x, I notice that the angle that's marked with x is next to another angle that's in the picture. Remember that consecutive angles are supplementary because a rhombus is a type of parallelogram. And so I can say that 2x minus 1 plus 127 is equal to 180 because those are consecutive angles. Going through and solving for x for that part, you would combine like terms, then subtract the 126 from both sides, and then finally finish by dividing by 2. So you get x equals 27. And then for the last part of this question to solve for y, notice that the y's are indicated on sides of the rhombus. All four sides of a rhombus are equal to one another in length. And so to solve for y, I'm going to set 6y minus 5 equal to 3y plus 7, and I'll go through and solve for y. So I'll minus the 3y from both sides, and then I'll add the 5 to both sides, and then finish by dividing by 3. So for this one, I'm going to get y equals 4. Anytime you're solving any problems that look like these, keep in mind that what you're trying to do is you're trying to remember the properties because the properties are going to tell you how to set up the equations that you need to solve to figure out the values that you're trying to find. And then everybody, just lastly, These properties that are stated here on the front side, you definitely want to commit these to memory. So you want to learn which ones are true about parallelograms, but then also which ones are true about rhombuses, and then lastly, which ones are true about rectangles. And then you want to remember that squares have all of these properties that are listed above.